Hello everyone. So in this video, we are going to be discussing the physical and chemical properties. Oops. So physical and chemical properties. At the same time as we're discussing these, we'll also talk about the physical and chemical change. If you understand one, you'll understand the other, right? So it's like saying one is a noun and one is the verb. Okay, so property is the noun, change is the verb. So physical and chemical. So let's take it very simple first of all. So think of the properties. So let's actually make a table for a physical property and then a table for chemical properties. Okay, so think of the properties as the characteristic. So physical property basically is the characteristics. So think of characteristics as the feature. So the characteristic that describes the physical identity. Okay. So like, how does something appear? If something is orange in color, if something looks solid, if something looks liquid or gaseous, or so things like that will be the physical characteristic. Okay. On the other hand, the chemical property will be it'll be the characteristic which describes the chemical identity. Okay. So here we're dealing with the chemical identity, which will tell me, what is inside that substance. Okay. So whenever you will be changing the physical property, you will cause the physical change. Whenever you will change the chemical identity of a molecule, you'll be calling that a chemical change. Okay, so a simple way to think of chemical change is that some type of chemical reaction will take place. So if carbon and oxygen were to come together and become carbon dioxide, do you see that the rearrangement of atoms have taken place? So think about this, guys. So think of carbon sitting in one container, right? And then think of oxygen sitting in another container. Now you combine both of them into a single container, and now you have made carbon dioxide, okay? So in this container, carbon was just by itself. In the second container, oxygen was just by itself. The compositions were just the carbon and just the oxygen, but then you combine them and now the arrangement has changed. Now you have made CO2, and CO2 is something like this. It's like carbon attached to oxygen on each end. This is what CO2 looks like. On the other hand, here oxygen was just this and carbon was just carbon element. Okay, so when you have just these elements, like so here you just have the carbon, here you have the oxygen like that. Now the arrangement of the atoms have changed. This is what the chemical change is. The chemical identity has changed. Here carbon was independent, oxygen was independent. Now they have changed into a molecule. So this is a chemical change whenever something like this happens. Okay. All right. So you will see that an exchange or transfer of the elements will take place when a chemical reaction is happening. Okay. So let's take some examples now of what a physical property would be like. So the first one we're going to talk about is boiling point. Okay. So when you say boiling point, also keep in mind the freezing point or the melting point. They are also physical properties. Okay. So why are these again boiling? Why are all these again physical property? So let's think about this. Okay. So what is boiling, first of all? When you try to change a liquid into a gas, so whenever you're changing, like water liquid into water, which is gaseous, basically when you're making it steam. So what have you done? The H2O molecule, when it's liquid, and then you heat it, heat is shown by this triangle. And when you change it into water and make it a gas, which is steam, you see that the H2O stayed H2O. It's not that the H2O actually broke into hydrogen and oxygen separate. So this is what the H2O molecule looks like, guys. Okay, we will learn Lewis structures later, but this is what water molecule looks like. This water on the left, which is the liquid water, and one on the right, which is the gaseous water, the structure stays the same. Okay, it is just the interaction between the molecules that changes. Okay, so so when you heat something, you are not actually breaking the bonds between that molecule itself. So you're not breaking the molecule unless, of course, you heat it way too much and then you start breaking the bonds. But when you're just boiling something, changing from liquid to gas, or when you're changing solid to a liquid, you're just breaking the intermolecular forces between the molecules, and this just separates the molecule away from each other. Okay, so they're just interacting less. That's all what is happening. So one H2O is just talking less to this neighboring H2O. That's what happens in gas. In liquid, they both talk to each other. When they're gas, they don't talk to each other. So that does not change the chemical identity of the water. So this is just the physical change, because this just affects the physical identity of the molecule. It just now appears that it has changed from liquid to a gas. Okay, so boiling point, freezing point, melting point, these are all physical characteristic or physical property. Okay, now on the other hand, what about the burning something? So when you burn something, so flammability, so the ability to burn something or to burn itself. So this is a chemical change, because you see it is the identity of that chemical that makes it susceptible to catch fire or not. So when you have a fuel, for example CH4, what do you do to burn it? So you of course need the ignition, and then you need the air, so oxygen, and it becomes carbon dioxide and water. This is basically what happens, guys, when you burn something. Okay, and this reaction is called combustion reaction. Okay, so when you burn something, you see fuel CH4 has changed into CO2. The arrangement of atoms have changed. Carbon was bonded to hydrogen here on the left-hand side. Now carbon is bonded to oxygen. So the identity, chemical identity has changed. Okay, so when you burn something, and usually you're also going to see that when you burn something, it's difficult to bring them back. So once you burn fuel, it's not possible for you to now change it back to that original fuel. So if you burn a piece of wood, or if you burn a piece of paper, you cannot bring the ashes back to the wood or the paper, right? So all of those are chemical changes. Okay, so similarly, think of corrosion. So if something is corrosive, okay, so this could mean two things. One, that the thing itself is corrosive. You see, it's said that the acids are considered corrosive. It is because of their chemical nature, because acids, they strip off electrons from other elements. Okay, so it actually leads to change in its chemical identity. So corrosion is also a chemical change. So for instance, if you see that the iron metal gets the metal there, like iron, it is susceptible to corrosion. What does that mean? It means that the iron can actually, in the presence of air, which is oxygen, can become iron oxide. And what does that mean? It means that, again, you have changed the arrangement, and this is nothing but corrosion. The iron actually got oxidized and became iron oxide, and you basically destroy the iron by doing this. So this is, again, a chemical change. Okay. All right, now let's take some more examples for the physical changes or physical properties. So guys, ductility and malleability, these are also physical properties. So ductility is where you can take, imagine a copper wire. I mean, you take a copper cylinder, like a cylindrical piece, and then you stretch it and try to change it into a long, thin wire of copper, and that is possible, right? In the case of metals. So that is the physical property of a metal, that you can change copper from this to this. So ductility is when you're able to deform without actually breaking or fracturing that metal. You can draw it into a thin wire. Okay. And on the other hand, malleability is where you beat, for example, aluminum metal, and you make it a very thin sheet, and then you, for example, change aluminum into aluminum foil. That is malleability. Okay, so that is also a physical property of a metal. Okay, so similarly, color is also an example of a physical property. For example, for color, listen to this carefully, okay? It's because it can both be a physical and chemical property. So color, for example, when you just observe a color, like the color of sky is blue, or when you say that the color of book is red, or when you say, the A4 paper sheet you're looking at is blue. All of those, the color itself, it is a physical property, okay? But on the other hand, the color change, okay? So color change, that is actually a chemical property or a chemical change. So why is that? So if the color of a solution changes, then something must have happened to the chemical identity. So for instance, you take one test tube, okay, and this test tube has chemical A, and then you take test tube number B, which has chemical B, and let's say this one is orange in color, okay, and B, there's some chemical sitting inside. You combine A and B into a test tube, and in this test tube, you have A and B both, okay? And they have done some reaction and they became C and D. And let's say that orange color disappeared. So it becomes colorless, or it changes into red color, or it changes into pink color, whatever change happens, okay? Whenever something like this happens, this must have happened because of a chemical change, because of the chemical property of that new molecule or new chemical that you have formed, okay? So and then on the other hand, you can say, if the color change is happening because somebody is painting a wall, then that is still a physical change or a physical property. So be careful when you're dealing with the color, okay? Because it can be physical or chemical, okay? Now, some more examples for physical chemical. So let's say another example would be viscosity. Think of viscosity. So viscosity is how fluid wants to travel, right? So how viscous something will be decided on how much resistance there is for something for a liquid to flow. So you can compare like water to maple syrup or honey, and we know like maple syrup and honey, they flow very slowly, and we say that they're more viscous. So that is again just a physical property of something. Okay. Now, on the other hand, for another example I want to discuss for chemical property will be, like a pH change, and then we're also going to compare that try to learn about the taste of something. So, guys, pH is basically, it is a measure. So pH is basically we'll learn this later on when you study acid and base, but for right now, pH is basically the measure of the H ions in a solution. So more H ions are present in a solution, the acidic that solution will be. And then on the pH scale, we will see that at the center, we call it 7, here it's 0, here it's 14. So the low pH is considered acidic, and the high pH is considered basic. Okay, so here you have very high concentration of H ion, Here you have very low concentration of H ion. Okay, so it is actually a physical property. We are dealing with this H plus ion if it's more or less. Okay, so pH is a chemical property, but then an observation of taste is also a physical property, because when you taste a lemonade, or you taste lemon basically, that sourness that you get from a lemon, or from a lemonade, it is basically coming from our tongue sensing how much acidic a lemon is. Okay, so since lemon is acidic, it has citric acid in it. Our tongue is able to detect that pH, and is translated into our brain as something being sour. Okay, and then on the opposite end, you have something which is basic and will be bitter in taste. Okay, so our body is just responding to those different pH levels in the food. So again, those are all chemical properties. Okay. Now, the last examples I want to discuss here for physical property is things like the mass, or the weight, volume, or the density. So all these things, where you just measure how heavy something is, how big something is, all of these are just a physical property, because it just tries to understand that how much matter is actually present in that given volume when you're, for example, calculating density. Okay, so I hope this made sense, and if you have any more questions, let me know. Okay, that's it for this video.